Lesson 7-6 is titled Exponential Functions. Alright, a real quick review. During the chapter when we talked about types of functions, we talked about a function that was a linear function. And a linear function we could write in the form y equals mx plus b. Now, one thing we knew about linear functions is they always produced a straight line. And when we had to write a rule for a linear function, we could do that if in the table, the xy table, if all the x's increased or decreased by the same amount and all the y's increased or decreased by the same amount. Then sometimes if a function was not linear, like this one, we called it nonlinear, and we usually knew a function was nonlinear if it had an exponent in its function. So we're going to talk specifically about those exponential functions today. An exponential function is a function in the form y equals a times b to the x power. There's your exponent that right away tells you this is an exponential function. It is not going to be a straight line. As you can see in the two examples, these lines curve. They are not straight. It's important to remember that. Alright, one way to tell by looking at a table if this function is exponential or not, you want to look at the x and y values. If the x values in the table have a constant difference and all the y values have a constant ratio, then the table represents an exponential function. Here's what I mean by difference and ratio. If all the x values have a constant difference, this means you can add and subtract a number to get your x values. So in this case, add 1, add 1, add 1. They have a common difference. And if you look at the y's, so x's you are adding or subtracting. In the y values to have a common ratio, this means you're either multiplying or dividing by the same number each time. So that's the difference between the two x and y. Negative 1 times 3 is negative 3. Times 3 is negative 9. Times 3 is negative 27. They have a common ratio. So in example A, I would say yes, the table represents an exponential function. There is a constant difference with the x values and a constant ratio with the y values. Let's look at example B. Is this an exponential function? Well, no, because the function is not in the form y equals a times b to the x power. There is an exponent of 2, however, it is important that with these functions, the exponent can only be x, okay? So it's the x values of your table that are going to be substituted in for your exponent value. So in this case, letter B was not an exponential function. Alright, evaluating an exponential function. Suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles each week. The function f of x equals 30 times 2 to the x power gives the population after x weeks. So x is how many weeks? How many beetles will there be after 56 days? Alright, well, first right away, since they're talking about x means weeks and they gave me a number of days, how many weeks is 56 days? 56 days is equal to 8 weeks because you can just divide by 7 days. So we're going to evaluate the function when x equals, when x equals 8. Okay, so in other words, to evaluate, it's very easy. You're just plugging the value in for x into your function. So it's going to be 30 times 2 to the 8th power. 30 times 2 to the 8th power is 256. My final answer is 7,680. So to answer the question, after 56 days, there will be 7,680 beetles. Okay? So again, just plugging in the value for x. Alright, graphing an exponential function. This is just like graphing any function, linear or not. They give you the function model. You make a table with your x values that you choose. Notice they picked a couple negative. 0 and a couple positive. I'm going to plug those x values into my equation. For example, y equals 3 times 2 to the negative second power. I can use my calculator. I'm going to do this for all my values of x. And what you get will be your xy coordinate. I'm just going to write the y's down here. When you plug in negative 2, I get 3/4. When I plug in negative 1, I get 1.5. When I plug in 0, I get 3. When I plug in 1, I get 6. And when I plug in 2, I get 12. Then I go over to my graph and I just plot those x, y coordinates. So negative 2 on the x-axis, up 3/4 on the y. Negative 1 on the x-axis, up 1.5. 0, up 1, 2, 3. 1 on x, up 6. And over 2, up 12, somewhere up here. So my graph is going to look something like this. I missed my points, but it's hard to do on here. Anyway, it's not a straight line, but it has a curve to it. It's an exponential function. So just plug in those x values that you choose into the function that they give you in the problem. All right, last example, graphing an exponential model. So it's a real life example. Computer mapping software allows you to zoom in on an area to view it in more detail. Here's the function, f of x equals 100 times 0.25 raised to the x. This models the percent of the original area the map shows after zooming in x amount of times. Graph the function. Here's our function. They gave us we start at 0 for our x value because you never zoom in a negative amount. So here's zooming in nothing, zooming in 1 time, 2 times, 3 times, 4 times. In our picture, here's our original map. Zoomed in 1 time, zoomed in 2 times. So we're getting closer and closer. We want to see how much area we can see after we zoom in an X amount of times. So I am going to plot those, or put these X values into my function. When I do that, I'm just going to cheat here and show you what I get. I get 100 for Y, 25, 6.25, 1.56 when I plug in 3, and finally when I plug in 4, 0.39. So then I graph my x and y values and I get something that looks like this. My plot's like this. It'd be a negative exponential function. Alright, those are the 4 examples for lesson 7-6. Please complete 1 through 4 and bring your answers to class.